Hello students. Today we are going to discuss about chemical equations. We already learned something about chemical equations in ninth class, right? So it's a symbolic representation of a chemical change, right? So before starting that, already we know some changes, physical change, chemical change. We studied about these in our previous classes. What is physical change? A change in its state, color, in its state, color and order, right? So here there is no chemical changes happening, so it can be irreversible. Suppose if you are squeezing a duster, right, that is a physical change, right? It comes to its original position, or tearing of paper, right, that also comes in physical paper. Here shape of the paper is changed, right? So if you paste it with a gum, so you can come reverse it, right? So that is physical change. So some examples of physical changes are breaking of chalk piece, boiling water, right? So what, when you are boiling water, what will happen? Water evaporates, right? So if it contains somewhere, suppose if you are boiling water in a container and it is closed with a lid, right? Whenever you are applying heat energy to this container, what will happen? Water evaporation starts here, right? Whenever it is touching the plate or lid, what will happen? Water condense on this plate, right? Again, it comes to container itself. So it's a physical change only, not chemical change. Melting of ice. So when ice melts, it become water. So again, if you keep the water in the deep freezer, so it becomes ice. So it is irreversible process, right? Mixing of sand and water, adding color to sand. Okay, these are all physical changes, right? Next, chemical change. What is chemical change? It is not irreversible change, right? In a chemical change, new substances are formed with properties completely unlike of those to the original substances. Okay, chemical change. In a chemical change, new substances are formed with properties completely unlike of those to the original substance. Completely new substances form. Suppose when hydrogen reacts with oxygen, so you'll get water, right? So hydrogen is a gas, and oxygen also gas. Whatever you are getting, water is liquid. Okay, completely different properties to this new substance. If you check these properties of hydrogen and gas, properties are by seeing only we can say it is gas, it is also gas. Whatever we are getting is a liquid, right? So whatever the end products we are getting are completely different, and the properties also different, right? So some of the new chemical changes happen surrounding to us are rusting of iron. Whenever you expose any iron nail or iron piece to the atmosphere, what will happen? It oxidizes with the atmosphere, right? So whenever it get oxidized, it forms rust. So it's a chemical change. Okay, next, digestion of food in our stomach. So it is mixing with the gastric juice, right? So it's a chemical change. Ripening of fruit, that also comes under chemical change. Burning of crackers. Whenever you burn crackers, it releases huge amount of heat energy, light energy, right? So end product is ash. Okay, so it is also comes under chemical change. Clear? Next, so in our lesson now, definition of chemical change. Chemical equation. Definition of chemical equation is the symbolic representation of a chemical change, right? That is our chemical equation. So what we are showing here, suppose whenever you are representing something in this form, so left side, left hand side, right hand side. Already we studied all this in ninth class, right? So left hand side, right hand side, left hand side. We will have reactants which are participating in the chemical change, right? Or chemical equation reaction, right? So whatever end products we are getting, those are called products. So here we got only one product, so it is represented. Suppose if we are getting one more product, so it is it is added by plus symbol, right? Okay, so that is a chemical equation. Chemical equation is the symbolic representation of a chemical change, right? So in this lesson we have some lab activities. So generally what changes you observe in the lab, right? First, activity 1 in your textbook, page number 23. So here what we are doing, take a beaker, add 1 gram of quick lime to the beaker and add water to this, and observe what changes you are observing here, right? If you touch this glass beaker, so it is somewhat warm or hot, right? So it means it is releasing heat energy in this reaction. Even though it is we are adding water, its beaker is hot, right? So it is called exothermic reaction. Releasing of heat energy is called exothermic reaction, right? So if you want to test the nature of the solution, right? So take blue litmus or red litmus. So if you are adding a red litmus paper to this solution, color of the red litmus paper will not change, right? Next, use blue litmus paper. Now blue litmus paper turns into red color. So what is the nature of the solution? It is acidic. It is acidic in nature. And right, next, sorry, here blue litmus is not turning, red litmus paper is turning into blue. So it is basic nature, not acidic. Basic in nature. Hence the product is base. Hence the product is base. Next, activity 2. Page number 23. We are having second activity. So here we have to take 2 beakers, add sodium sulfate in 1 beaker, 10 grams of sodium sulfate with 100 ml of water. Right. Next, barium chloride with 100 ml of water. Right. Both are colorless solutions. Mix these two. So what I am doing, I am pouring all the solution into the barium chloride. Sodium sulfate is added to barium chloride solution. What will happen? So here you will observe some white color structure in this beaker. So what it means, it is forming precipitation or salt. Okay. So it forms precipitation after reaction, after stirring everything here. So you will see some salt like structure here, right? So some salt is formed here, that is called precipitation. So equation related to, you can write this here. For this is Na2SO4 reacts with barium chloride, gives out barium sulfate plus sodium chloride. Sodium chloride is a salt, so which is in the form of precipitation, right? Precipitation settles down in the bottom of the beaker, right? Next, activity 3. These are the different activities we are doing here. So we have to observe what changes are happening in a chemical reaction. What are the end products we are getting? Other than end products, what we are getting? So to observe that only we are doing these simple lab activities, right? So take a beaker, conical flask. So it is conical flask. Add some zinc granule to this conical flask. Add diluted hydrochloric acid to this conical flask and close this or conical flask with cork. So after some time, you will observe that some gas tries to escape from the conical flask. So if you want to test it, bring a burning mastic. So what will happen to this burning mastic? Burning mastic put off with pop zone. So we observe that gas is evolving out, mastic put off with pop zone. These are the changes we observe here, right? So what is our simple lab activity? Zinc granules are reacted with hydrochloric acid. Zinc granules are reacted with hydrochloric acid. What are the end products? So hydrogen gas released, zinc chloride is formed. Okay. So these are the simple lab activities. From these 3 simple lab activities, what we are observing, in first lab activity, heat is released. In second lab activity, precipitation formed. In second lab activity, precipitation formed. In third lab activity, it is releasing some gas which is putting off You are burning mastic, right, with pop sound. Okay. From the above activities, we can conclude that so heat may be liberated or absorbed. Okay, exothermic, endothermic reaction. If it is releasing heat energy, it is if it is releasing heat energy, it is called exothermic reaction. Releasing heat energy. Suppose if you are burning a cracker, what will happen? So it releases huge amount of heat energy, right? So that is comes under exothermic reaction. Endothermic reaction. So to happen this reaction, it takes heat energy externally, right? So here, these are the simple examples we can consider here. Photosynthesis we learned in biology, right? So it happens in the presence of sunlight only. Sunlight is a form of energy. So it is also endothermic reaction. Evaporation of water. To evaporate water, what we have to do, we have to apply heat energy externally, right? Melting of ice cube. Whenever it gets heat energy, then only heat energy or ice is 0 degrees Celsius. Atmosphere temperature is 36 degrees or 37 degrees, right? So it is more than, so whatever heat energy getting from the atmosphere converts ice cube into water, right? So it is taking externally from the atmosphere. So it is also endothermic reaction. Lighting of a candle, to burn candle or lighten, so we need external heat energy, right? Bursting of crackers, here we get huge amount of heat energy. So this all comes under endothermic, right? Endothermic reactions. Exothermic means it releases heat energy. Endothermic means it absorbs heat energy. Absorbs. Clear? Right. Next, so it may release heat energy or it may absorb heat energy. Second one, the original substance may lose their characteristic properties and new products are formed. After any chemical reaction, this is common thing. New substances formed with complete new properties, right? So new substances or new products are formed. They may form insoluble substance known as precipitate. After any chemical reaction, it may form precipitate. So may, we are using the word may, so it may form precipitation. Right? Gas may be evolved. In some chemical reactions, gas may be evolved. So mostly we'll get hydrogen when metals react with acids. Sometimes it releases carbon dioxide. Whenever you are burning something, it releases carbon dioxide, right? So gas may be evolved. Next, chemical equation definition is given here. Chemical equation is the symbolic representation of a chemical change. So every chemical equation is represented like this. Every chemical equation will have left hand side, right hand side. Left hand side we are having reactants. Right hand side we are having products. Here we will get products, right? So this is LHS, right side is RHS. So it is this arrow going to the product side only, right? Right. Suppose, ah, so in products maybe one or two or three. So if you are getting one more new product, so I am adding plus sign. Suppose if you are getting here some gas, it is added like with plus sign. Okay. Next, reactants. Definition of reactants: substances which undergo a chemical change, which undergo a chemical change in the reactions are called reactants. Substances which participate in the chemical reactions are called reactants. Right. Next, products, new substances are formed as a result of the chemical change. As a result, we will get here after chemical reaction, we will get new substances, right? Those are called products. So, why should we write a chemical equation? So, suppose if you are writing a chemical equation, suppose yes, we are using this word hydrogen plus water gives what? H2O, right? So, it is, we are using formula of the instead of writing hydrogen, we are writing formula of hydrogen. Instead of writing oxygen, we are writing oxygen O2 formula, right? So it is a simple representation, easy to understand, occupies less space. So all these are advantages of the writing chemical equation, right? So what are the advantages of writing a chemical equation? Important one: represent of a chemical equation or reaction become easy, means easy to understand. It saves time and saves space in writing. So if you write same equation, hydrogen plus oxygen, it takes more space, so we have to read whole thing at a time. If you represent it with formula, by seeing this only we can read it as hydrogen. By seeing this we'll read it as oxygen, right? So it is easy to understand, it occupies less space, it saves time, easy to understand the relation between reactants and the products. So easy to understand the relation between reactants and the products. In order to prepare a definite amount of the product, the amount of the reactant to be used can be calculated accurately, right? So suppose uh, if you want to prepare some chemical, right? So two products, some more, don't take this as example. Suppose if you are want to produce it, I'll take one example: Fe2 or Fe2 aluminum and Fe2O3 aluminum is reacting. What it gives out generally, Fe, so aluminum oxide forms Al2O3 plus Fe, ferrous oxide. So it's a raw material. So I want only iron, right? So how much of amount you need? Suppose if you want to get 100 kgs of iron, how much of ferrous oxide should be used? How much we need aluminum? What are the end products? How much we are getting? Everything can be calculated by using these chemical reactions or chemical equations, right? Exactly, we can calculate how much. Okay. Next, after this, our next topic is balancing a chemical equation. Balancing a chemical equation, very very important topic. So by practicing only we'll get this one, right? So according to law of conservation of mass, the total mass of the products formed in a chemical reaction must be equal to the total mass of the reactants consumed, right? So already we studied in ninth class that nothing is created, nothing is destroyed on the earth, right? So it is changing its physical state. Suppose if you, in previous equation we studied hydrogen plus oxygen, two gases are combining to give out water is a liquid form, right? Suppose if you are burning in third lab activity, in this hydrogen gas is evolved, we have to consider, even though it is trying to escape from this container, we have to calculate the weight of the hydrogen gas before. Weight of the product weight of the reactants should be equal to the weight of the products. Both should be equal. Even though hydrogen gas is escaping from that place, we have to consider that weight of the hydrogen gas. That is law of conservation of mass, right? So based on law of conservation of mass, uh, total mass of the products formed in a chemical reaction must be equal to the total mass of the reactants consumed. Product of mass equals to mass of the products equals to mass of the reactants, right? See here, first example, C3 plus C3H8 gives plus oxygen gives out carbon dioxide and water, right? So what are the elements present here? So here carbon dioxide present, hydrogen, oxygen. Right hand side also we are having carbon dioxide, oxygen, hydrogen and oxygen. So both two times we have oxygen. So we have to balance it. So if you see this left hand side we are having three carbon molecules, right? Right hand side we have only one. So it's not balanced. This type of equations are called skeleton skeleton equations. Skeleton equations, right? Unbalanced chemical equation is called a skeleton equation. So here, to balance the equation, first you have to do one thing. Draw the box like this. Every time you have to draw the box. So first column, elements. So generally we have here only three elements, CHO. So only take one. After balancing carbon, then only go for hydrogen, then oxygen. Right? If you have a confusion, which one we have to take first? So observe the chemical equation. Okay. So see, we will see first how to balance it, right? So elements left hand side, right hand side, how many are there we have to calculate. Carbons left hand side we have 3, right hand side only 1, right? So 1. So we cannot decrease carbon molecules, so we can increase by them by multiplying 3. So we are having only one option to increase it, not to decrease it, right? So right hand side we have to multiply with 3. So after that you write again whole equation, C3H8. Don't add simply here 3 like this, you will get confusion. So C3H8 plus O2 gives out 3CO2 plus H2. Okay, now again draw your box here. So I am drawing here only. Elements, every time you have to write elements, and LHS, RHS, right? Carbons left hand side, how many are there? 3. Right hand side 3. 3, this 3 should be multiplied with oxygen and carbon both, right? So here 3 3 carbons are same. Next go with the hydrogen. So I am going with hydrogen only. How many are there on left side? 8. Right side only 2. So we should not decrease 8. We can increase 2 by multiplying it with 4. 4 to the 8. 8. So what we have to do? So multiply right side your hydrogen with 4. So C3H8 plus O2 gives out 3CO2 plus 4H2O. Okay. Draw a box again. So carbons left hand side we have 3, right hand side 3. Hydrogens, how many are there? Right side 8. Here we have 2 only. 2 is multiplied with 4. 2 4 is 8. Next oxygen, right side 2. Left side, see here. Here we have 2 oxygen 3 times. Means here we have 6. How many we have here? 1 oxygen 4 times 4. 10. So what we have to do? So 10 cannot be decreased. It is multiply your left hand side with 5. So check once again what we have to write. C3H8 plus O2 gives out 3CO2 plus here we have to add 5 and 4H2O. Okay, now check here elements. Carbons 3, 3, hydrogens 8, 4 to the 8 here, oxygens 5 to the 10, here 6 plus 4, 10. So left hand side elements, how many are there? Right side that many are there. So it's a balanced equation. So it's a balanced equation. Clear? This is the way to balance the chemical equation. Right? You may have doubt here. So sometimes you may get, so here oxygen molecules are splitted. So here we have 6, here 1. So in this situation, better to go with the hydrogen only. Hydrogen can be balanced easily. Then next will be calculated easily. Then, right? Next example. Next example is NaOH plus H2SO4 gives out Na2SO4 plus H2. Right? So I'm not writing again it. Just drawing the box. Elements LHS, RHS. So first what I am taking, I am not going with the H. Here is a confusion. Hydrogen. So sodium first. Sodium. Left hand side we have 1. Right hand side 2. What we have to do? Multiply left hand side with the 2. So whereas sodium is present, there only you multiply here. Don't write 2 here. Okay. So I am writing again 2 NaOH plus H2SO4 gives out Na2 H2O. Okay. Right. Again draw your box. Elements LHS, RHS. Right. Sodium 2, right hand side 2, left hand side 2, right hand side 2. So hydrogens. I'm going with the hydrogen now. So here 2 should be multiplied with this hydrogen also. So it is applicable to oxygen, hydrogen and sodium 3 times. We have to multiply. 2 sodiums are present, 2 oxygens are present, 2 hydrogens are present. So here we have 2, here we have 2, total 4. Right hand side we have only 2. What we have to do? Multiply right side with the 2. So 2, here we have 4, 2 2s are 4. Right? 2 NaOH. Write clearly your equation, then only you will understand easily. Na2SO4 plus 2H2O. So hydrogens are balanced. Again write your box here. Elements LHS, RHS. So sodium, every time you have to check each and every element. Right side 2, left side 2. Hydrogens, left side 4, right side 4. Then go with the oxygens. Oxygen, here we have 2 oxygens, here we have 4. Total 6. So oxygens 4, here we have 6. Okay. So what left? Sulfur. We have only one sulfur here. Here we have only one sulfur. 1, 1. So it's a balanced equation. What is our balanced equation? 2 NaOH plus H2SO4 gives out Na2SO4. So write small letters, small only. Then only you'll understand it is single compound and 2H2O. Balanced equation. It's a balanced equation. So this is the way. First what we are checking? Sodium. Left side we have only 1. Right side 2. So multiply your left side with 2. So here both will be same. 2, 2. Right? What I am doing? I am adding, multiplying it with 2. Okay? Right? Next again check here. Elements. Sodium. Left side 2. Right side 2. Hydrogens. Left side 4. Right side only we have 2. So multiply your right side with 2. So what I am doing? 2. I multiply whole water molecule with 2. Not for single hydrogen. Right? So check your sodiums. Left side 2, right side 2. Next, go with hydrogens. Left side 2 plus 2, 4. Here we have 2 2s are 4. Next, go with the oxygens. Oxygen. Left side here we have 2. Here we have 4. Right? 2 are there. 2 plus 4, 6. Right side 4 already we have here 2. Here we have 2. 2 plus 4, 6. Sulfur SS 1 1. So what is our balanced equation? 2 NaOH plus H2SO4 gives out Na2SO4 plus 2H2O. So this is our balanced equation. I think you are understanding slowly how to balance it. Right? Next example, KClO3 plus KCl plus O2. So again draw a box. Elements LHS, element LHS, RHS. Okay. So first what I am taking, potassium K 1. Left side we have only 1. Right side also 1. Next chlorine. Chlorine 1. Right side also 1. But oxygen 3 2. So here we have to balance first oxygen. So you cannot convert 2 to 3, you cannot decrease it to 3 2. So what you have to do is to find LCM for 3 and 2. What you will get here, 6 is your LCM, right? So multiply your left side with 2, right side with 3. Okay, left side with 2, both the sides I am changing, not single side. Left side I am multiplying with 2, right side I am multiplying with 3. So it will become E6. Here also you will get 6. Okay, right. So 2 KClO3 gives out KCl plus 3O2. Check here elements again. LHS, RHS. So first what you will have to check K. Every time you check all the elements. Left side how many are there? 2. Right side 1. Stopped here again. So what we have to do, multiply it with 2. Right? So check again. 2 KClO3 gives out 2 KCl plus 3O2. LHS, RHS. Right? So again comes, check it from K. Left hand side we have 2, right hand side 2, left hand side 2, right hand side 2. 2 should be multiplied with the K with this chlorine, both. Okay. Here also 2 should be multiplied with K. How many? 1 are 1 into 2, 2. Chlorines how many are there? 1. 1 into 2, 2. Oxygen 3 into 6, 6. So chlorines how many are there? 2. Right hand side also 2. Oxygens 2 3 is 6, 3 2 is 6, 6 6 balanced. Clear? So what is our balanced equation? 2 KClO3 gives out 2 KCl plus 3O2 is our balanced equation. It is our balanced equation. Very, very important topic. Right? Next example. So draw a box. Okay. RHS. Okay. Mm. Right, right, right. Hg, mercury, left side 1, right side 1, 1, 1. Here, see, this 2 should be multiplied both with N and oxygen. So, how many nitrogens are there? 2. How many oxygens are there? Already we are having 3. 3 should be multiplied with 2. Total 6 are there, oxygen, nitrogen 1. So, nitrogens, left side 2, right side 1 only. This 3 belongs to oxygen only. But what we have here, it is within the bracket subscript 2. For this bracket we have subscript 2. It means this 2 belongs to sodium as well as oxygen, right? So here right side we have only 1. So what we have to do, multiply it with 2, right? So next write your equation again. HgNO3 plus Ki HgI2 plus 2KNO3. Check your elements again. Element LHS, RHS. Every time, even though it is taking time, we have to draw it. Hydrogens, left side 1, right side 1. So next sodium, sorry, nitrogen it is, sorry, I'm saying sodium. Nitrogens, how many nitrogens are there? Left side 2, right side 2. So balanced it is. Next go with the oxygens. How many are there? 6. Right side 3 multiplied with 2. 6. Next going with K. Left side 1, right side 2. Stop here only. So it is not balanced, so I am stopping here only. All these are balanced, but it is not balanced. Multiply it with a 2. Right? Now again write your equation. HgNO3 2 plus HgI2 plus 2KNO3. Right? So left side 2. Here we have to write 2. Maybe here it is balanced. Element LHS, RHS, right? So Hg 1 1, nitrogen 2 2, nitrogens are 2, here 2 nitrogens. Next oxygen 6 6. Next potassium 2, right side. Here we have 2, here we have 2. Next iodine, left side 2, right side 2. So balanced. Every element is same on left side and right hand side. What is our balanced equation? So HgNO3 2Ki gives out HgI2 plus 2KNO3. So this is our balanced equation. Right? Next example. Next example. Again draw your box. LHS, RHS. Okay. Right. So here there is a confusion. Here how many carbons are there? 6. Here we have 2. Here we have 1. Total 3 only. So leave it for a while. So we will go with the hydrogens. Hydrogens left side we have 12. Right side here we have 5. Here we have 1. Total how many? 6. Clear? 5 plus 1, 6. So what we can do here? Multiply it with 2. 12, 12. Okay. C6H12O6 gives out 2C2H5OH plus CO2. Right? So again check your elements. LHS, RHS. Hydrogens 12, right side 10, 5 twos are 10, right? Again 2 ones are 2. So here we have 10, here we have 2. Total 12. Okay. Next, go with oxygen. Oxygens. Left side we have 6. Right side 1 here. So 2 here and 2 here. Total 4. So what we can do here, suppose if you multiply here with 2, it will become 4. 4 plus 2 6. So what I am doing, simply I am multiplying it with 2. So it is splitted. No, I am total here only I am multiplying, not here. Get the idea, please. 2C2H5OH plus 2CO2. Now check your elements again. So hydrogens 12, right side 12, oxygens 6. So here we have 2, 4, 6. Balanced. So if you are trying to do LCM, that is a wrong way. We cannot go here with LCM. If it is a single compound, we can go with that. Okay. Right. Next, what left? Carbon. Carbon left side 6, right side. Here we have 4, 2, 6. What? Balanced. What is our balanced equation? C6H12O6 gives out 2C2H5OH plus 2CO2 is our balanced equation. Clear? So small change here. See here. This is the thing we have to observe. Special case. Clear? Right. Right. One more equation. NH3Cl. Draw your box again. Element LHS, RHS, sodium, sorry, nitrogen. Left side 1, right side, leave it for a while. So I'll go with the chlorine directly. Chlorine left side 2, right side 1. So we can multiply it with 2. Right? So NH3 plus Cl2, N2 plus NH4, 2 NH4Cl. So check your element again. LHS, RHS. Okay. So chlorine. I'm checking chlorine first. So left side 2, right side 2. Okay. Next, hydrogens. I'm going with hydrogen, or you can go with the nitrogen also. No problem. No. Why? Because it is changed here. Odd number became even. 2 plus 2, 4. Left side 1, right side 4. So multiply your left side with 4 directly. Right? So 4 NH3 plus Cl2 gives out N2 plus 2 NH4Cl. Right? Check your elements again. RHS. Right? Here we have 4 nitrogens. So 4. Right, so also here we have 2, here we have 2, 4, total 4. Next, again chlorine 2, right side 2. Hydrogens, left side 12. NH3. Here we have 12. Here we have 8. So there is a confusion again. What we can do here? Find LCM for 12 and 8. 4 3s are 4 2s are 4 12, 12 to the 24. So it should be multiplied with 3. Check once. Rough work I am doing here, don't write. Hydrogens, if I multiply with 2, everything will be changed. It will become 8. Nitrogens become 8. Here 3, 6. Again, wait a second. I want one more paper. I am doing one rough work. So multiplying with 2, no? Left side 2 means here 8. NH3 plus Cl2 N2 plus right side 3 means 3 2 is 6. 6 NH4 Cl. Everything is changed here. Hydrogen is changed, chlorine is changed, nitrogen changed. Right? So 2 plus where we have to multiply hydrogens. 24, 24. Nitrogens 8. 6 plus 2 8. Chlorines 2. Here 6. Okay. Now we can balance it easily. Right? LHS, RHS. Nitrogen, I am taking nitrogens. 8. Here we have 2, 6, total 8. 6 plus 2, 8. Hydrogens, 24. 3 8s are 24. So 6 4s are 24. Okay. Chlorine. How many chlorines are there on left side? 2. Right side 6. So simple thing, multiply it with 3. So 8 NH3 plus 3 Cl2 gives out N2 plus 6 NH4 Cl. Now check your elements again. It's a lengthy equation. Element LHS RHS. Right? See nitrogens. How many nitrogens are there? 8. 2 plus 6. 8. 8. Balanced. Hydrogens 24. Here we have 24. 4 6 is 24. No? Chlorines 6 on left side. 2 3 is 6. Here 6 directly. Multiply chlorine 6. So what is your balanced equation? 8 NH3 plus 3 Cl2 gives out N2 plus 6 NH4 Cl. This is your balanced equation. Lengthy one. So it is our balanced equation. Going to see if you want to write like this. First onwards like this. Clear? Right. Next, last example. So this is your homework. Try to complete it. So simple one only I gave. Simple. Sodium 1, 1. Hydrogens left side 2, right side 3. So if you multiply it with, so I'll write balanced equation. Only answer I am writing. Remaining is your homework. Practice at home. Plus H2. So what I am doing, I am multiplying with 2. Sodiums. Check your sodiums 2. 2. Hydrogens 2. Left side 4. So 4. 2 plus 2 4. Oxygen's 2. This is your balanced equation. Remaining you solve. Okay. Right. Next topic, moving to next topic. Making chemical equation more informative. Okay, making chemical equation more informative. How to make chemical equations more informative means what information you should add to the chemical equation to get the more information from that equation. Suppose if you are mentioning its physical states, so if it is gas means represent it with the upward arrow, right? Is it releasing heat energy? Is it need external heat energy? All this should be included in the chemical equation to understand in a better way. Very important question, right? So chemical equations can be made more informative by expressing following characteristics of the reactants and products. Reactants means we can here add a physical state of the reactant. It is solid, liquid, or aqueous, right? What are the end products we are getting? It is easy releasing gas means it is represented by upward arrow. Precipitation formed means represented by downward arrow. All this. First one, physical state, solid, liquid, gas, and aqueous. Solids, so we know which is in a solid form, it is represented by S. Subscript, in subscript we have to write, suppose sodium, what, so I Fe2O3. So it's a solid, right? Write like this, subscript, right? Liquids with L, gases with G. Aqueous is a new word for you. Suppose if you are adding something to the water, that is called aqueous. If you are mixing something in the water, that is called represented by aqueous. Right? Suppose after chemical reaction, a product formed within the water, so that is also represented by aqueous. Clear? So that is the difference between liquid and aqueous. Next. See here, Fe2O3 solid, aluminum is a solid. So what this delta represents? So this delta represents represents heating. So in this, to happen this chemical reaction, we need or we have to apply heat energy externally. So what we are generally we heat it with Bunsen burner or a spirit lamp like that, no? So that represented by delta, right? So all these are solids formed again, right? Heat changes already we discussed exothermic or endothermic, right? Exothermic means releasing heat energy. Endothermic means absorbing heat energy like photosynthesis. It means to happen the reaction it need heat energy, so that is called endothermic reaction, right? So how to remember this? So simple way to remember one logic to remember this is exo means externally heat energy released, externally means releasing outside, so that is the logic to remember this one. Gas evolved is represented by upward arrow, okay? Gas, upward arrow in the bracket, right? Precipitation formed, precipitation, so represented by downward arrow, okay? So these are the four states to get we have to add this information to a chemical reaction to make the chemical equation more informative. Suppose you are using upward arrow somewhere means there that is gas. By saying this only I can say gas. Downward arrow represent precipitation, right? Exothermic and exothermic is represented by sorry plus q. Suppose in a equation, suppose in this example it is releasing heat energy means I'll add q plus q like this, okay? Heat energy is released exothermic, so minus q if I added, that is endothermic reaction, minus q like this, endothermic reaction, right? Next example, very very important. Calculate amount of aluminum required to get 1120 kg of iron when it react with ferrous oxide, okay? So first you write the equation. So generally they'll give uh, atomic weight of the aluminum. They'll give within the question sometimes. Otherwise you have to remember. Otherwise you have to double your atomic number. You will get it. Fe 56 units and oxygen. Oxygen number is 8 now. If you double it, you will get atomic mass. Okay, so aluminum 27, iron 56, oxygen 16. Okay, first what is given in the question? Read it. So calculate the amount of aluminum required to get 1120 kg of iron when it react with the ferrous oxide. Aluminum react with ferrous oxide. So what you will get? Iron and aluminum oxide. So what we need? This one they are asking, right? So this is our skeleton equation. 2Al balanced it. After balancing, we know how to balance it, right? Check your elements. 2 aluminiums 2, 2 ferrous, ferrous 2, oxygens 3. Here we have 3. So it's a balanced equation, right? See here. Now substitute your element weights here, atomic weights. So in the place of aluminum, 2 into 27, right? Right. See here. This one, okay, simple one. Fe2O3. So how many ferrous iron is there? Or ferrous 2, weight 56, plus it should be added with the plus 3 into atomic weight of oxygen is 16. Okay, so it is single compound, so it should be within the bracket, added by with plus sign. Okay, right side. 2Al means 2 aluminiums plus 3 oxygens plus 2 ferrous. So both should be balanced. 56. 56 2s are plus 16 3s are, you'll get after adding 160. Here 1 or 2. 27 2s are 54, you will get 48. Total 1 or 2 you will get here. Here 54, 48. And 112. Total 214, 214. Balanced. Left side how much weight is there? Right side how much weight? See here. What is our question? How much amount of aluminum required to get 1100 kg of iron, right? So from this what you are getting, how much of iron we are getting here? 112 iron. How much we used here? Aluminum 54 kgs of aluminum to get the 112 units of iron. Not kgs, I am using units only. Okay, to get 112 units of iron. Now how much I need here from this chemical equation? 54, right? From, so see here, aluminum how much required, iron how much got? 54. If I used 54 grams, I got 112 grams of iron. Means what, from what they are asking in the question, to get 1120 kg of iron, how much aluminum I should use in the reaction, or okay, so simply cross multiply it. So this one total comes, kg is written in grams, 1120 into 54 by 112. Total 540. Mostly you will get this type of questions only. Clear? So with this topic completed, your whole chemical equations lesson completed. Thank you.